right, so let's do some more Racket hacking. Tonight I'm going to talk about hashes in Racket. So we can create a hash. We're going to do x to y, 1 to 2, and the string h to the word hello. All right, so we can create a hash using the function hash in Racket. And then we pass it a series of key value pairs. The idea is that we pass a key in every odd position, I guess, if you're, well, even position if you're counting from 0. And in the next, so for index 1 or index 3 in the argument list, you'll pass the corresponding value. Sorry, I think I made that more complicated than it should have been. But basically, you pass pairs of keys and values. And then it produces a hash for you. This is the way that Racket prints hashes. There are a few useful functions. So you can do hashref of a hash, and then let's say x, symbol x, and it gives us back y. So let's say I define this to be x. There are a few things I can do with hashes. So, for example, I can grab the list of keys. So I can print hash keys x. I can also get the value, or get the values. So I can print hash values of x. That will give me all the values. Someone asked me earlier today if they were always sent in the same order. And you know, that's kind of a hard question to answer because really the order is kind of non-deterministic in some sense. What I mean by that is that the order will just, you can't really depend on the order in any way. You kind of have to think of these as sort of sets of values. I don't think the API gives us anything specific back about it. And of course I can iterate over the set of values just by using traditional functions like map. So for example, I could map all the keys. I could map over all the keys of x. And I could do whatever I wanted with them. Maybe I could print out, maybe I could display ln format and then 2 arguments and take the key and then its corresponding value. And what I would do there is I would, in my map, I would print out the key, and then I would print out hashref, and then I need to give, hashref takes the hash, which in this case is just x, and it also takes the key that I want to access. So I can take key right here. All right, and then I can run this function. Let's see what happens. And it should print out all the keys and values. Ooh, that's not good. Ooh, nope. I meant the word format. Change that a little bit. Format should have been the function. And then this just returns void, void, void. So really the answer is that I should try to do something like a for loop or something like that. But we haven't really talked about those yet. So for now, it's just kind of safe to say it doesn't really matter that this just returns void, void, void. The reason it does is because the result of display ln is the value void. And so if we map over it, it's going to produce 3 of those for us. All right. So now I want to set up a I want to set up an exercise with hashes that will kind of prepare us for the project assignment 1 in 352. And so a big part of that assignment deals with taking a hash map and manipulating it in some way, or basically reconstructing it in some way. So for example, let's say that I've got the hash define, or let's say that I've got the PageRank, which I'm going to call. Say that I've got hash in 0 is going to be 0, in 1 is going to be 1/2, and in 2 is going to be 1/2. Let's just say I want to write a function called sum PageRank for some PageRank. Well, I can do this a few different ways. I'm going to do it maybe the most obvious way for students who haven't thought about folds in a while, which is that I'm just going to write a tail recursive function called loop that iterates over each key in the PageRank and then accumulates some value. So now what I'm going to do here is I'm going to say, oh, no, I'm silly. So yeah, I need to be looping over a list of keys. And then I need to recognize when that list of keys is empty, then I'm just going to return this accumulator. Otherwise, I'm going to have some head and some tail. And I'm going to sum, or I'm going to pass to the next iteration of the loop, tail, which is going to say keep operating or keep looping on the tail. It's a recursive call, but it's a tail recursive call. So keep looping on the tail, and then add head to the accumulator. All right. And now we'll loop over hash keys, PR, and 0. And then now let's do sum PageRank of PR. And I'm being a little bit sloppy here, I'm going to point out, because let's call this EXPR. We don't want to shadow names. We want to be careful not to shadow names in our code. That's kind of bad style, because it's easily going to lead to us getting confused. Oh, crud. I need to update the definitions window. Sum PageRank of XPR. Okay, this is good. We've got a contract violation. And the reason is that I tried to just add the head to the accumulator. Okay, so what do I need to do instead? What I need to do instead is I need to look up in the hash the key, or sorry, the value corresponding to the key in the head of this list right here. All right, so let's try that again, see if it works. Okay. Oh, silly me. Hash ref. Okay, good. So it returns the result 1, which is what I expected. Now, let's ask a question. What would I have done if instead of just wanting to sum all the elements in the hash, I had wanted to maybe build up a new hash or something like that? Maybe I wanted to set all of the elements of the domain to 0. or sorry, say I wanted to set all of the values to 0, let's say, right? How would I do that? Well, first, I have to observe that my accumulator can't be a number, can't be something like 0. It has to be a hash table. And then here, when I'm updating it, what I'm doing here is I'm taking the plus of the number right here and this accumulator. So that's going to update this number. We can sort of think of the accumulator as the state we're kind of keeping throughout the tail recursive function as it evolves, or throughout the loop as it evolves. And instead, I can sort of do this. I can say hash set. I want to set the accumulator so that the key HD is set to 0. All right, so I'm updating accumulator. I'm sort of pulling off each of the keys, and one by one I'm setting them so that the values are 0 for the corresponding key. And then I pass that to the next invocation of loop to handle the tail. All right. And this is 0 PageRank. And by the way, this is not right because this is not technically a PageRank anymore. If you look at the PageRank predicate, it will require that the codomain sums to 1, so that it always forms a probability distribution. But this is just kind of for the purposes of illustrating that we might be able to rebuild the hash. And this is going to be a useful pattern for you when you write your own code. Okay, so we could have done this another way as well. So let's write 0 PageRank, which, again, it's not a PageRank. So let's maybe call it 0 hash. All right, so 0 hash. Again. This time I'm going to use the function foldL to walk through the list. So I'm going to call foldL. I need to give it a lambda that's going to take a next value and an accumulator. What I'm going to do is I'm going to hash set the accumulator for that next key. Really, this is next key. When I set that to 0, I'm going to start with the empty hash, because this is the 0. If you don't kind of get what's going on here, go back and watch my video on folds in Racket. So that's our 0 case. And then we're going to fold over the keys. And I misspelled define the whole time. All right, there we go. So given that, I think that if you look over some of this code and think about how you can sort of change it, a lot of the answers to the project A1, or I guess what's really on the auto grader is P1-1 because I messed it up so many times. But I think a lot of the answers to those questions can be found just by sort of manipulating and messing around and reorganizing some of these functions. So I think if you do that, you'll find out that you'll be able to get it done. So best of luck.